Welcome back to the Deep Dive. We're continuing our exploration of those Lucasian professors of mathematics at Cambridge.
A lineage of brilliant minds.
Oh yeah, they shaped the world of science, and this time we're zeroing in on the very first person to hold that prestigious position, Isaac Barrow.
Isaac Barrow, yeah.
Okay.
While often overshadowed by his, famous student, Isaac Newton,
Right.
Barrow's contributions are incredibly significant, particularly in laying the groundwork for calculus.
Yeah. His work is often overlooked. You're absolutely right. So let's delve a little deeper into Barrow's journey.
Mm-hmm.
His early life, for instance, wasn't a straightforward path to academic success. I read that his father even prayed that if he had to lose a child, Isaac would be the one.
Oh, wow. Yeah, his early education was marked by both struggles and surprising bursts of academic excellence. At Charterhouse School, he was known for being disruptive, even a bit pugnacious. But a transfer to Felsted School under headmaster Martin Holbeach proved to be a turning point. He thrived there, excelling in both classics and mathematics.
It makes you wonder how many brilliant minds might be out there needing the right environment to truly flourish.
Right.
So after Felsted, Barrow continued his studies at Trinity College, Cambridge, right?
Yes, and he continued to shine academically, earning his degree in 1648 and a fellowship just a year later. However, the English Civil War disrupted his trajectory. As a staunch royalist, he refused to sign an oath supporting the Commonwealth government, which effectively put his academic aspirations on hold.
What a difficult situation to be in. So how did he navigate this period of a forced exile?
Rather than accepting defeat, Barrow embarked on an incredible 4-year journey across Europe, even venturing into the Ottoman Empire. He fought off pirates, honed his courage, and absorbed knowledge from diverse cultures. It seems this period of exile fueled his intellectual curiosity even further.
That's quite an adventurous detour on his academic path. Did these experiences influence his work when he returned to England in 1659?
Absolutely. He came back a more mature and seasoned scholar, and with the Restoration in 1660, the political landscape shifted in his favor. He was ordained and appointed Regius Professor of Greek at Cambridge, marking his official return to academia. He also took on the role of Professor of Geometry at Gresham College in London in 1662. Then, in 1663, came the pivotal moment. Isaac Barrow became the first Lucasian Professor of Mathematics at Cambridge.
That's a pretty rapid ascent back into the academic world.
Right.
It speaks volumes about his capabilities and growing reputation. His tenure as a Lucasian professor wasn't merely about accolades, though, was it? Wasn't this the period where his groundbreaking work truly came to light?
Exactly. Barrow's research focused primarily on the properties of tangents. Which might sound a bit dry at first, but believe me, this is where things get fascinating.
I'm all ears. Tangents and their properties.
Oh.
How did this shape the course of mathematical history?
Well, Barrow's work on tangents was essentially laying the foundation for what we know today as calculus. He was exploring fundamental concepts of slopes and areas under curves, ideas that would later be formalized by Newton and Leibniz.
Considering his work on tangents, would you say that Barrow was a pioneer in the field of calculus, even if he didn't formalize it in the way Newton and Leibniz did?
Absolutely. He developed innovative methods for determining the areas and tangents of curves. And get this, he was the first to calculate the tangents of what's known as the kappa curve.
For our listeners who may not be familiar with the intricacies of geometric curves, could you elaborate on the kappa curve and why calculating its tangent was such a significant achievement for Barrow?
Imagine a shape resembling the Greek letter kappa. Finding a tangent to a curve at a specific point is like finding the line that grazes the curve at that exact spot, giving you information about the curve's direction and rate of change. The kappa curve, due to its unique curvature, presents challenges in determining tangents. Barrow's success in calculating its tangent demonstrated the power and broader applicability of his method to diverse mathematical problems. His approach foreshadowed the steps we use in differential calculus today.
It's amazing to think about how he was already thinking in terms of instantaneous rates of change, even before the formalization of calculus.
Precisely. And what's even more intriguing is that his intellectual pursuits weren't confined to just geometry. He also delved deeply into the field of optics.
Optics? That's quite a leap from geometry. How did his mathematical research intersect with the study of light?
Light travels in paths, and analyzing those paths can be done through mathematical principles. Barrow focused on reflection and refraction, or how light bends when passing through different mediums. He even simplified Descartes' explanation of rainbows, making it more accessible.
So not only was he shaping the future of calculus, but he was also making strides in the study of light.
He was a true polymath. And on top of all that, he was a prolific writer, publishing editions of Euclid's Elements and works by Archimedes and Apollonius. He was a true champion of spreading knowledge.
It sounds like he was driven by a deep desire to understand the world and to share that understanding with others. But let's go back to his student, Isaac Newton. You mentioned earlier their relationship was a remarkable part of Barrow's story. Could you elaborate on that?
In 1669, Barrow did something extraordinary. He stepped down from the Lucasian Professorship to make way for his student, Isaac Newton.
That's an incredible display of humility and a testament to his belief in Newton's potential.
Exactly. He recognized Newton's genius and saw the value in giving him the space and resources to flourish. This wasn't just a personal gesture, it was a pivotal moment in the history of science, paving the way for Newton's groundbreaking work.
It's a beautiful example of academic collaboration and the passing of the torch, so to speak. Sadly, though, Barrow's life was cut short at the age of 46.
Yes, he died in London in 1677.
Okay.
However, in that relatively short time, he made an indelible mark on the world of mathematics. He established the Lucasian chair as a beacon of mathematical excellence, setting the stage for centuries of groundbreaking discoveries.
It's amazing to think about the chain reaction he set off, leading to some of the most important scientific advancements in human history. But before we delve into Newton's contributions, let's take a moment to fully appreciate Isaac Barrow's legacy and the lasting impact he had on the world of mathematics.
Barrow's work, though often overshadowed by Newton's, is finally gaining recognition for its crucial role in shaping the future of mathematics. He truly was an unsung hero, laying the groundwork for some of the most important mathematical concepts we use today.
It's fascinating how progress in science is often incremental, building upon the contributions of many, some of whom may not receive the same level of recognition.
Precisely. Barrow's story reminds us that scientific breakthroughs often happen in stages, with each contribution playing a crucial role.
For those of us who might not specialize in mathematics, could you provide more context on the revolutionary nature of calculus and the significance of Barrow's work on tangents? What exactly made it so important?
Before calculus, mathematicians primarily dealt with constant rates of change. Think about the speed of an object moving at a steady pace. However, the world is full of dynamic situations with constantly varying rates of change. Imagine a ball thrown into the air. It's continuously speeding up and slowing down due to gravity.
I see. So how did calculus address these complex scenarios that involve constant change?
Calculus gave us the tools to analyze such dynamic situations. It allowed us to calculate instantaneous rates of change, find the slope of a curve at any point, and determine the area under a curve, which represents things like the total distance traveled by that ball.
So Barrow's work on tangents was essentially a stepping stone toward these groundbreaking applications of calculus.
Exactly. By developing methods to find tangents to curves, he was exploring the concept of a derivative, a core element of differential calculus. It was like he was laying the first bricks of a path that Newton and Leibniz would later pave and expand upon.
His work on tangents was clearly foundational. But wasn't Barrow also a scholar beyond mathematics and optics? Didn't he have other intellectual pursuits?
You're right. Initially, he was a professor of Greek, highlighting his strong background in classical scholarship. Later in life, after stepping down from the Lucasian chair, he devoted himself to theology, even writing a treatise on papal supremacy.
A true Renaissance man. It's fascinating how his intellectual curiosity spanned across such a broad range of disciplines.
This intellectual breadth is reflected in his writing style as well. His sermons, for example, were known for their clarity and elegance, blending logical reasoning with wit and humor.
His diverse interests certainly paint a picture of a remarkable intellect. Switching gears slightly, we often hear about the lone genius toiling away in isolation. Was this the case for Barrow? Or did he benefit from a network of colleagues and collaborators?
Barrow wasn't working in isolation. Remember, this was the heart of the scientific revolution, a period of immense intellectual ferment. He was part of a vibrant community of scholars who exchanged ideas, debated theories, and pushed each other to new heights.
So it was more of a collaborative symphony of discovery rather than a solo performance.
Precisely. And that's a key takeaway for our listeners today. Scientific progress rarely happens in a vacuum. It's a collective effort, built upon the contributions of countless individuals, each playing their part in the grand orchestra of knowledge.
That's a beautiful analogy. And it makes me appreciate the importance of mentorship and collaboration in the scientific world. We need those figures like Isaac Barrow who are willing to nurture the next generation of thinkers and innovators.
Absolutely. It's about recognizing potential, providing guidance, and sometimes, as in Barrow's case, stepping aside to let that brilliance shine. It's a testament to the power of shared knowledge and the enduring legacy of intellectual generosity.
Well said. But before we move on to delve into the life and work of his illustrious student, Isaac Newton, let's take a moment to reflect on what we've learned about Isaac Barrow. What key insights or takeaways would you like to leave our listeners with?
I think the most important takeaway is that scientific progress is a collaborative process. Isaac Barrow, while not as famous as Newton, made significant contributions to mathematics, especially in laying the groundwork for calculus. His work on tangents was truly revolutionary for its time.
Yeah, it's also fascinating how his story highlights the importance of mentorship. Stepping down from the Lucasian Professorship to make way for Newton speaks volumes about his character and his commitment to advancing knowledge.
Absolutely. It's a reminder that recognizing and nurturing talent is essential for the progress of science. We need more individuals like Barrow who are willing to support and guide the next generation of thinkers.
Yeah, and his story also demonstrates that brilliance can emerge from kind of unexpected places. He wasn't always a model student, and his journey included periods of exile and adventure. Yet these experiences seem to have shaped his intellect and fueled his curiosity.
Yeah. His diverse interests, spanning from classics and mathematics to optics and theology, also challenged the stereotype of the solitary, single-minded genius. Barrow's intellectual breadth and his ability to connect seemingly disparate fields remind us that innovation often arises at the intersection of different disciplines.
As we conclude our deep dive into the life and work of Isaac Barrow, it's clear that his impact extends far beyond his own achievements. He not only made significant contributions to mathematics, but also shaped the future of science by recognizing and supporting the genius of Isaac Newton.
His story serves as a powerful reminder that scientific progress is a collective endeavor. It's a testament to the importance of collaboration, mentorship, and the enduring legacy of intellectual generosity.
Well said. And with that, we conclude our exploration of Isaac Barrow, the first Lucasian Professor of Mathematics at Cambridge. Next time, we'll delve into the life and work of his illustrious student, Sir Isaac Newton. Get ready to explore the world of physics and the laws that govern our universe. Until then, keep exploring, keep questioning, and never stop learning.